Yeah, Kamsan everyone. Let's start off. Sure. Last thing that we did was the rod hanging. Sure. Kamsan everyone. Let's go ahead. Let's do a few more. Let's say we have an incline here. This angle is theta. We have a spear here, and top of a spear there is a rod. This rod is hinged here. This is a rod of mass m and length L. So basically, the edge of the rod is passing through the center. This is a solid cylinder. This mass is also capital M and radius is R. And the incline is rough. Even the rod is also rough. All surfaces are rough. Right? Rests on a cylinder as shown. So all surfaces are rough, meaning even the rod is rough. Huh? So if you want, I'll write it down. So there is a friction between the rod and the cylinder also. And there is no slipping at any surface. So basically the system is in equilibrium. Find all frictions and normal reactions. Hmm. So just to give an idea, how many normals are there? Here there is one normal reaction, there is one friction. Here there is one normal reaction, there is one friction. So yeah, I want you to find these four basically. There is a normal between the rod and the cylinder, there's a normal between the cylinder and the incline, and there are two frictions also. Let's get them. Again, remember the process is still the same. Step one, choose a system, draw the FBD. Now there are two systems, you have to draw two FBDs. Apply force equations, in x direction, y direction, apply torque equation, solve. The concept is still the same. I just made the problem more lengthier and tougher. Let's go ahead with this. And others do keep your cams on. I'll give you a minute, then I'll show you the free body diagrams. Let's see whether you got the free body diagrams right, though. Friction between the rod and the sphere is mgl by 2r. Let's see. I don't know the answers actually. I don't remember the answer. But interestingly, why did you get L in the answer? That looks right, Ravia. What you got? Ishman, एक बार check करो ना. I think you goofed up somewhere. Sure, let me show you the free body diagram. First, let's check whether you got the FBD right. First thing, the rod. What are the forces? Hinge reaction, Ny, Nx. This guy is pushing up, N1. And what about the friction? Think about this. If the cylinder is trying to go away, on the cylinder, friction will be this way. So on this rod, the friction will be this way. And your own weight mg. There, total 4 forces and n ka 2 components. Check your free body diagram there. Now balance the forces in the vertical direction. Do we need to do that? We can do that. I'll just take torque. Take torque about point A. If I take torque about point A, again torque due to Nx, torque due to Ny, torque due to F1, torque due to mg, and torque due to N1 must be 0 because rod is in equilibrium. This guy is gone, this guy is gone, and this guy is gone because all are passing through the axis. So this will be mgl by 2 minus k cap, and that will be n1 into L plus k cap is equal to 0. So we get n1 is equal to mg by 2. Perfect, we got one. We got n1 without actually doing much, but okay. And I don't think I will write the force equations because I don't want nx, ny. I didn't ask you that. So, and I don't think I'll get f1 from only this thing. So I need to draw the sphere anyways. Now, if you draw the sphere, same story. You're pushing from top n1. Then you'll push left side with f1. This will pass through the center. This will be n2, which is passing through the center. This is f2. This is your own weight mg. Again, total 5 forces. Check your FPD there. And what about this angle here? If this is theta, this angle will be 90 minus theta. So this angle is also theta. So this angle is theta. I actually already know N1, right? So you can clearly see if I take torque about this point, if I take torque about this point B, N2 ka torque will be 0, F2 ka torque will be 0, mg ka torque I can calculate, N1 ka torque I can calculate because N1 I already know. That means I'll get F1 ka value. Isn't it? That way. And once I got F1, I can do even something better. If I take torque about the center, I'll call it C. If I take torque about the center, we get torque due to mg, torque due to n2. I'll stop writing this later on, but for now I'll write a few more times. Torque due to f1 and torque due to f2 must be 0. Through the center, mg is passing. through the center N2 is passing, through the center N1 is passing. You can clearly see here, you'll get F1R K cap minus F2R minus K cap is 0. So basically you'll get F1 is equal to F2. That's a pretty good result. So there is no need to find them separately. Now find the torque about B. If you find torque about B, you will get F1 ka value, then automatically F2 ka value you will get. And think then you can draw the forces ka equation and get N2 also. Try. I'll give another 2 minutes now. Calculate. I did all the major work for you. Like I said, if you draw a free body diagram, you will start seeing things. And it is important, like, choosing the points properly will make you save your time. You will get the answers. But please ask me if there's any doubt on this page. So you have to be smart in choosing which point I should take torque. So taking about the center N1, N2, Mg3 are gone. F1, F2 became equal because the perpendicular distances are same. If I get N1 and F1, I can find even Nx, Ny hinge reaction also. So now find torque about B. That should give you F1. And then write a force equation that will give you N2. You got everything. Try. I'll give 2-3 minutes. It's a little brute force calculation. It's a little work. Let's see the thing. So you're trying to take torque about B, right? So we need perpendicular distances. So extend the vector, drop the perpendicular. Remember, this is radius R. So this distance will be R sine theta. Similarly, this distance will be r cos theta, and this distance will be r. So that will be the perpendicular distance to F1. So if you take torque about B, torque due to N2, torque due to F2, torque due to N1, torque due to mg plus torque due to F1 must be 0 because it's an equilibrium. N2 is gone, F2 is gone. N1 ka torque will be N1 plus mg. Both are actually in the same direction, and perpendicular distance is r sine theta. And how is the rotation? Remember, B is the axis. So this is the rod, and you're pushing down the rod. So you're pushing the rod down, so it will rotate downward. That is clockwise. Hope you're able to visualize the direction ka thing. So assume that perpendicular distance like a rod, and the force is pushing the rod down. So the rod will rotate clockwise. And then this would be minus k cap. And then F1 ka torque will be F1 into r plus r cos theta. That direction will be plus k cap is equal to 0. F1 and N1 ka value is how much? Mg by 2. So substitute there. That will be 3 mg by 2 r sine theta by r into 1 plus cos theta. R goes off. We end up with F1 is equal to 3 mg sine theta by 2 into 1 plus cos theta. You can simplify this further. You can write sine theta as 2 sine theta by 2 cos theta by 2 and cos theta as 2 cos square theta by 2, and then you'll get some tan theta by 2. You can play around. That would be 3 mg by 2 tan theta by 2. This is your F1, and this will also be equal to F2 because we proved it just now. Perfect. Now we need to find still N2. I think I can resolve the components in the vertical direction or maybe the horizontal direction. That will be better, and I'll get it from there. This is N2. If that is theta, this would be, this is also theta. This is also theta. So if you write in the horizontal direction, N2 ka sine theta must be equal to F2 ka cos theta plus F1. But I know F1 is equal to F2. Therefore, that will be F1 into 1 plus cos theta by sine theta. So you can substitute there, you get the answer. Actually, you'll get a good answer here. Because F1 is 3 mg sine theta by cos theta. No? Take this guy, substitute here. That sine theta will cancel, cos theta will cancel. You'll be ending up with simply 3 mg by 2. That was interesting. There. Check the calculations though, but clear this. I got everything. I got N1, N2, F1, F2. Yeah, I got everything. There, like I said, it's little lengthy. You just have to keep solving, keep solving, keep solving. You'll get it. But again, like I said, the process is still the same. Draw your FBD, write your force equations, write your torque equations, solve. All clear with this. This is the problem here. Yeah. There was a rod on top of a cylinder, and cylinder is on an incline. The whole system was at rest. Find all the normal reactions and all the frictions. That was the question. You can try later on. Clear? So that's a little bit about equilibrium, and then going ahead, we have toppling. So what is this toppling? Now, when you take a block and put it on a floor, When we say normal reaction, where is this normal reaction exactly acting? If you actually think about this, the N is acting at every point where it is in contact. So for convenience, what we do, we always write the average basically. We say the N is acting at the center, like just like mg is acting at every point, we take the average. So here normal reaction is actually distributed uniformly on the surface. So when you don't apply any force on the body. Right? So, and for it to be in equilibrium, we take the N exactly under the center of mass. Because, or else there will be a rotation, there will be a torque, and the body will rotate. I think this part of the screen is gone, I guess. For equilibrium, and passes through center of mass. Because there is no other force, there's only mg and N, so torque about center should be 0. Fair enough. What happens if you apply a force? This is what actually happens. Think of like this. Now you're sitting in a chair, right? Try to lean towards right side. If you try to lean towards right side, you'll observe most of your weight is falling on your right thigh, isn't it? Your left thigh is lifting off the chair and your right thigh is, pushing the chair more. Same thing, if I go more to the left, you'll observe the weight shifts more to the left side, leg compared to the right leg. Can you see? That means your normal reaction is not always acting at one point. If you shift your weight, your normal is also changing. So if you try to, let's say, apply a force F here, now you can clearly see there is a more tendency of the body, right? So the right side of the body gets pushed more. If someone pushes you to the right, you'll start standing on your right leg and your left leg starts lifting off the ground. So right part of the block experiences more normal reaction. Than the left part. So when you draw FBDs, so this is the thing, we didn't bother about this thing in loss of motion because you treated the body as a point object. It never mattered, but now it will matter. So whenever you're drawing a free body diagram, always don't put N exactly under mg. We will put N something to the side like this. Where we don't know, we can calculate that, but for now we don't know. So we will always draw an FBD like this and will be little to the side. That is the main thing in toppling problems. And how do you know you have to do that? And it's not a regular NLM problem. I'll show you a question, you'll understand. The wordings in the question will give you a hint whether should I consider toppling or not consider toppling. Right? Then if you keep on applying more and more force, the body starts balancing on the edge. Right? And if further F increases, body topples. So whenever they say in the question, right, the body is about to topple, then you have to draw the FBD like this. So you should just know how to draw the FBD under what scenario. So this whole body, right, is just standing on that corner. So your normal reaction will shift to this corner. So if there is any friction involved, then friction also. So NF everything will be the thing. So keep this in mind. Whenever they say the body is about to topple, this is the FBD they're expecting. If they say force F is acting on the body, and if it is not toppling, then this is the FBD you're expecting. If it is not toppling, N will still shift. We don't know where. That's it. So toppling, that's the main concept there. Clear with this? Any doubt on this page? Great. Let's see a question then. We got a cuboid, mass M. This is A, and this is 3A. And let's say there's no slipping on the floor. Means you have enough friction so that the body will not slide. And now you started applying a force F somewhere here. First question, let's say if F is equal to mg by 4, find the position of the normal reaction. Understand one thing, when there's a no slipping, there is some force on the ground which is not letting it slip. So there is a friction. So you need to understand that when there is a word no slipping, there is a high chance there is a friction involved. They won't mention it in the question directly. Second question, if what is the maximum force you can apply if the body, find F max, if the body does not topple. You don't want the body, when I say topple, I don't want the body to become like this. I don't want the body to lift off and, rotate. Let's get this. The question, like I said, right? How do you know it is like a NLM problem and it is not an, it's a rotational problem? Tell me one thing, till now, in everything that I taught you, did you ever see the dimensions of a block? In laws of motion, friction, circular motion, any time did you see, anywhere, the dimensions of the block? We never bothered, right? That is the first clue. Second thing, they're not asking find normal reaction, they're asking find the position of normal reaction. That is your second clue. And you can clearly see body does not topple. The word itself is there, topple. The moment you see the word topple, it's a rotation based question. It is not only pure NLM. Clear with this? So there are actually 3 hints in the question. So that is how you know, boss, this question is not pure NLM, but it is a rotation based question. The first thing, the dimensions of the block. You have never seen dimensions of the block before. We didn't need them, right? Because we never considered rotation. Meaning, you know what? This is what we did till now. When I said a block of mass m is placed on the incline, we didn't care whether the block is like this or we didn't care whether the block is like this. We assumed both are going with g sine theta. Do you really think this guy will go with g sine theta? Even before it slides, won't it start toppling? Starts falling down, isn't it? We have not considered those kind of cases till now. Now we will do. Okay. Looks right, Samyak. Let's see. Step one, draw your remember, this is still equilibrium problem only. You're not doing something new. So what are the forces? Normal reaction, it will be somewhere here. Your weight mg will be some here. And remember, there's also friction. Huh? Friction will be here on the floor. Now friction will be everywhere. So I don't know exactly. It's not a single point. This is distance x. Perfect. Since it is not moving, F must be equal to friction and N must be equal to mg because it is an equilibrium. Next thing, you can take torque about any point. Generally, you can actually choose this point. That will be the safest point because in one N and F ka torque will go off. But if the body starts slipping, then you can't take this point because then it will become a non-inertial frame. So just to be on the safe side, I will take center of mass. You can actually take any point because the whole thing was at rest. So if you take torque about center of mass, we'll have torque due to mg, torque due to friction, torque due to n, and torque due to f must be 0. mg ka torque is 0. Friction ka torque will be, this is the perpendicular distance. This is a by 2. This is also a by 2. So this will be friction into a by 2. Which way is the rotation? This way. F is pushing to the left. So that will rotate anti-clockwise minus k cap. Capital F is also pushing that way. This will be n into x plus k cap. F into that is also a by 2 minus k cap. Basically, capital F and small f are forming a couple. So we had nx is equal to fa. And we know n is equal to mg. So x is equal to fa by mg. That's your general solution. So for the first case, you said f is equal to mg by 4. Therefore, x is equal to a by 4. So there, the n is not in the center, it is a by 4 to the side. Second problem, you said you don't want to slip. Now ask yourself, how much can the n move? Let's say if you apply more force, n from here will shift to the here. If you apply more force, then it will shift to here. More force, it will shift to the corner. Meaning there is a limit to how much n can go, right? N cannot go outside the block, isn't it? Because n is a force due to the contact. That means there is a limit how much you can exceed the value of x. So x ka value here must be less than or equal to 3a by 2. That is half of the side. X ka value cannot exceed this corner ka length. So if I substitute here, this will be Fa by mg must be less than equal to 3a by 2. So this is the condition for no toppling. As long as the n is within the boundary, you won't topple. If n has to go outside, meaning you toppled. So we'll get f is less than equal to 3mg by 2. So therefore, f max is 3mg by 2. You exceed 3mg by 2, you're going to topple. Is that clear, everyone? Sure, what we did? Let's see one more like this. So toppling is not something really out of the world or anything. You have to know only two things. One, the n won't be in the center anymore. It will be little to the side. Where we don't know. Let it be x and you have to start solving. Second, if you say the body is about to topple, that n must be go to the corner. Bus. These are the two things that you learned in toppling. Other than that, it's your regular equilibrium problem only. Let's say we have this and we have a block. This is A and this is B. Find the condition if the block slides but does not topple. So I want the block to slide. I don't want the block to, become like this. I don't want block to start rolling. So condition meaning it will come between A, B, mu, and theta. Find the condition if the block slides but does not topple. There'll be two conditions, right, Shaurya? The previous question, why x will be less than 3a by 2? Because देखो ना, the total, this is 3a na given. So from the center till this point, what is this distance? 3a by 2. So now you tell me, the normal cannot go outside, na? It has to be within that region. Yeah, yeah. Maybe if you guys want, I'll write it down. N cannot, n has to be within the base. Yeah, that people do get confused. What about this guy? Hmm, A, B, mu, theta, okay. Nere Samyak. How did you get that? Friction is not given. Chalo, let's see. Step 1, draw the free body diagram. What are the forces? I'll divide mg into components, mg cos theta, mg sin theta. The normal will be somewhere here. Friction will be somewhere here. Let this distance be x. Getting it? I am keeping it as simple as possible. This distance is a. This distance is b. First of all, you're slipping, right? Since it slips, the friction must have become maximum. Mg sin theta must be greater than or equal to f max. Basically, the angle is greater than angle of repose, if you remember. Mg sin theta must be greater than equal to mu into mg cos theta. So mu must be less than equal to tan theta. So if mg sin theta is greater than mu mg cos theta, this is the one condition. So tan theta is greater than equal to mu. This is, it will slip. Second thing, you don't want it to topple. Fair enough. So let's take torque about the center of mass. That will be torque due to mg, torque due to f max, torque due to n must be 0, and mg is anyway 0. F ka torque will be f into b must be equal to n ka torque will be n into x. But what is f max? F max is mu mg cos theta only, mu into n. This is n into x. So n gets cancelled. We get x is equal to mu b. But remember, x ka value cannot exceed, again same story, x ka value cannot exceed a by 2. Isn't it? Because that is half of the cube length. From here to here, this length is a by 2. You cannot exceed a by 2. So this will give you the second inequality. Mu must be less than equal to a by 2b. I think that is also b by 2, na? This is also b by 2. So mu must be less than equal to a by b. So there we have to satisfy these two conditions. Now we don't know which is smaller, huh? So it is a union mu less than tan theta, mu less than a by b. So example, let's say you have theta is 45, and let's say a is equal to 1 and b is equal to 2. Then the first condition says mu is less than 1. The second condition says mu is less than half. So the answer will be mu is less than half, isn't it? I can play the other way also. Let's say a is 2 and b is 1. Then mu will be less than 2. Then theta 45 will dominate. So we're not sure actually. You will take the minimum of these two. A smaller value. Clear with that? So this would be the answer. Clear with this? Then you can play like this. So toppling questions are nothing much. They're always like this only. They'll ask you find the condition for toppling. Where is the n? Any doubts on this? Mu should be not greater than equal. But how did you get a mu without that a and b ka thing? So you got mu greater than a by b, na re? Reverse लिखा होगा कहीं पे तूने. So x must be, this is the condition for no toppling, right? As long as x is within a by 2, you don't topple. I think maybe you took mu greater than, and maybe हो सकता है. Clear with this? There, that's about your torque. So now you know how to calculate torque, and you know how to write the torque equation about any point. You know everything. That's our first part in the chapter, calculating torque. The second part, moment of inertia. Like I said, there are three parts. You should know how to calculate torques, how to calculate moment of inertia, and no slipping condition. Arya.
Sir, I have a doubt that when we actually say the normal is shifting, can you please
Mm-hmm.
explain why the normal shifts? I mean, I got the mathematical approach key. If you sit on the COM, then no other force is there to reverse the
You're not
torque.
listening, yeah? When I explained the whole thing, pura story to wahi bataya tha. I told you if you shift to the right side, your weight will shift to your right leg. If you shift to the left side, your weight will shift to the left leg. N is not actually single point, right? When you say normal is acting, there's normal is not acting at a single point. For convenience, you take it at one single point. Tell me one thing, when I say mg is acting on a body, is mg acting only at center of mass? It acts at every point on the body, but
Yeah,
for
but
convenience for solving, you take it at the center of mass. It is just a
okay.
mathematical construct, meaning the whole problem will behave as if mg is acting at the center of mass. Similarly, if there is no force acting, again by symmetry, every point is exerting same amount of force, right? Then we can say n is acting here. For example, if you take a body like this, now can you still argue like there will be same n everywhere?
No, it's
नहीं ना,
on.
definitely right side will be more n, तो normal reaction यही कहीं पे होगा. It shifted. It will not
Yes,
be
sir.
always in the center. बस वही था.
Okay, sir.
Just like, think of like that. You don't have a doubt about mg. Even though weight is acting at every point on the body, you take it at center of mass. Same way, even though n is acting at every point, you take it at one single point. It is an equivalent.
Okay, sir.
Oh, yeah. तो वो है. Next thing is moment of inertia. So what makes this chapter a little different from NLM, right? In NLM, F is equal to MA. If I give you force F, you know force F. Your life was easy. If I give you mass, you know mass. Life was easy, right? So you just have to find it. But in rotation, when it's a torque is equal to I alpha, we're going to see that we have to calculate torque separately, we have to calculate I separately, then we have to find alpha. So that's what makes it a little more lengthy. Getting it? So moment of inertia is I when I say this. So what is this exactly? Consider a body rotating with an angular velocity, angular acceleration alpha. So we have taken some random body and let's say it is purely rotating about an axis with an angular acceleration alpha. So now if you consider a particle here, mi, at a distance of ri, and when it is going in a circle, so this particle will have a tangential acceleration, which is ai is equal to ri alpha. Why am I not writing ri alpha I? Do you guys remember the starting of the chapter? If one point goes with alpha, then every point goes with alpha. They all rotate by the same angles. Basically, this is your tangential acceleration of the particle. This will give you the tangential force on the particle Fi, which will be mi into ai. And then when you write the torque here, so the torque on the ith particle will be ri into Fi. They're already perpendicular because it's a tangential force. This would be ri into mi, and ai is ri alpha. So we get torque on one particle will be mi ri square alpha. So the total torque will be summation sigma torque I will be sigma mi ri square alpha. So what people noticed, this thing, right, is looking like F is equal to ma. And this is not the only time. Later on, we will see this term will always keep popping up. We get torque is equal to, we write this thing as I into alpha, where I ka value is given by sigma mi ri square. So since this term keeps popping up every time, we decided, first let's calculate in the first place, and then let's do it in the problems directly. It's like cooking only. You're keeping the ingredients ready even before you start solving the problems. So what is this Ri? Now this is important. Again, whenever I say R, always be careful. Don't think it is position vector. Here Ri is the perpendicular distance from the axis. In torque is equal to R cross F, what is R? R is a vector from the axis to the point where force is applied. In work done, integral F bar dot dr, what is that R? Displacement of point of application of force. You're getting? All R's are not same. They mean different things. So this is the perpendicular distance from the axis. This is not the position vector. The moment of inertia is actually a tensor, right? Again, when I say tensor, let's not get into it, but think of like this. If you take your, let's say if I take my phone here, right? If I catch here and rotate, it feels okay. But when I catch on the edge and rotate, it becomes more difficult. So same body, same mass, same dimensions, but suddenly it started becoming more difficult. So these properties, right, just don't depend only on the, the magnitude and the direction, but they also depend on other quantities like axis of rotation and everything. There's a much better definition, but we don't need it. Tomorrow, if you become a civil or a mechanical engineer, they'll teach you. So don't worry. But for now, at 11th and 12th, moment of inertia behaves like a scalar for a given axis. Let's keep it simple. So you can add moment of inertia about a given axis of rotation. So this is the perpendicular distance from the axis. So what is the physical significance? You can clearly see more the moment of inertia will have lesser the half. So higher the moment of inertia, just like mass. What is the meaning of mass? More the mass, more difficult to accelerate the body. Higher the moment of inertia, more difficult to rotate the body. Vice versa. If it starts rotating, more difficult to stop the body. Basically, it's a rotational inertia. Mass is translational inertia. This is similar to mass in translation. There, this is one new formula. So straightforward. What is moment of inertia? Sigma mi r square. So again, whatever you learned in center of mass, all those integration stuff will pop up again. Yeah.
Sir, I wanted to ask, like, can you explain what a tensor is in simple language? I mean,
Ignore it, na. You can find it online.
okay, sir.
Why bol raha hu? Let's not waste your time. Like bola na, it depends on the axis. For example, if I rotate this body about this axis, if I rotate the body about this axis, and if I rotate the body about this axis, or by changing the axis, it is becoming more difficult to rotate. So for the same body, right, it is depending on how you take the axis. It is not only depending on your direction. It is not only depending on your what do you call magnitude. It is also depending on something else, orientation.
Okay, sir.
So that is one kind of thing. But even in tensors, there is something called ranks of tensors. Basically, a zero rank tensor is a scalar. First rank tensor is a vector. Second rank tensor, third rank tensor. They use matrices to solve. So let's not get into it. It's complex and हमको चाहिए नहीं. फिर
Okay,
भी you're
sir.
interested, there is a video of that float head physics करके. There is a guy. He will explain it very beautifully, 15-20 minutes. But you can watch that after your IIT exam gets over. So for now, let's focus on G. Yeah, there is nothing wrong to be curious, but problem क्या होता है ना? You already have enough things to get confused. But the guy का channel name is Floathead Physics. That is the first time I heard that and I actually understood what is the tensor. But we don't need it, so don't worry. For now, at our level, we will treat it like a scalar. Keep it simple. So there, for particles, the formula is sigma mi ri square. In the beginning of my career, I used to teach everything. I used to explain that, this, and later on I understood. At some point, right, people used to mix up everything. They used to overthink in the exam. They used to goof up everything. So I understood. Being a teacher, now I also need to control like how much I should actually teach. It's we think like teach matlab sab sikha do. No, we don't need to do that. If you do that, then it will be an overload for you guys. So you guys need to understand that here we are not only learning physics. Our primary objective is to crack the exam, and then secondary objective is to learn physics. Why? Because if you learn physics, you can crack the exam. Unfortunately, that is the situation. Getting it? Technically speaking, we should have focused more on the subject, but then no one gives a damn about it. You might be thinking, sir, how being a teacher, how can you say that? Best thing, go to your parents and ask them, Mama, should I learn physics for the sake of learning or should I get into IIT? And see what answer you get. Right? I will learn physics very beautifully. I'll be one of the great physics person, but unfortunately, I will not get a good college. I'll join Don Bosco Engineering College and then see what will happen. So unfortunately, that's the situation there. So don't worry, but still, we are learning as much physics as possible. You're still interested. Once you go to IIT, first semester, you have physics again. Right? Even if you go to BITS or NITs, they will teach you PCM again in the first semester. You can definitely learn at a much higher level. What you're asking. So again, be careful in this thing. Na, the most common thing people goof up that R only. R is the perpendicular distance. So let me just put it down again. So that's your integral form. And luckily, na, unlike center of mass, moment of inertia is actually a little easy to calculate. Because in center of mass, we had XCOM, YCOM, ZCOM. Here, there's nothing like that. But you should definitely mug up these results. Huh? We have a lot of results here. You need to remember all of them. Like I said, if you don't know how to calculate torque, if you don't remember the moment of inertia results, you can't even go ahead with the questions. So moment of inertia, mi behaves like a scalar for a given axis. So if you take a given axis and moment of inertia about that axis, you can just simply add them up like a scalar for a given axis. So you cannot add ix and iy directly. Suppose if there is one axis here and there's one axis, you can't add them. So, but about the same axis, you can keep adding them for a given axis of rotation. Moment of inertia is actually a tensor. So if you really want to study tensors, you need to study vectors actually. This is how they represent moment of inertia in a tensor. Ixx, Ixy, Ixz, Ixy, Iyx, Iyy, Iyz. Matlab, there are actually 9 directions you have for moment of inertia in that thing, depending on which axis you take. So anyways, clear? Let's see a question. That's it. Moment of inertia, there are only two formulas we have. For particle, sigma mi rs square. For continuous bodies, integral dm r square. So important thing, the axis will be always given. So this is an axis. Let's say this is mass m, this is 2m, and this is 3m. Let this distance be d. Let this distance be 2d. Let this distance be 3d. Find moment of inertia. It's an easy one, but I want to make a point here. Let's say this distance is 2d. Find moment of inertia. Yeah, it's an easy one. So you can clearly see what is the value of I. Mass into perpendicular distance. So m ka perpendicular distance is d. 2m ka perpendicular distance is 2d. So 2m into 2d square. 3m ka perpendicular distance is 3d. So 3m into 3d square. And the value is 36 md square. Same for both. So this is important. Huh? That means I really don't care how you keep the particles. What it depends is only the perpendicular distance. Means as long as the distribution of mass, right? If the distance is same, it doesn't matter about the orientation. So moment of inertia is independent of orientation of particles. Means you keep the particle at a distance of 1 meter in front of you, behind you, left side, right side, it doesn't matter as long as the perpendicular distance is same. Quite a useful thing. It will be quite useful when you're integrating. It will actually, eliminate some integrations for you later on. So it's a very powerful statement. Yeah, it's a straightforward thing. Independent of orientation of particles. So as long as you keep the perpendicular distance same or the mass distribution same, you can keep the body however you want. As long as the perpendicular distance from the axis remains same. Next thing. X. This is Y and this is Z. There is a particle here of mass m whose coordinates are x comma y comma z. Find the moment of inertia about x-axis, y-axis, and z-axis. Again, did you observe one thing? If someone asks you find moment of inertia, your first question, sir, about which axis? If someone asks you find torque, about which axis? If you don't ask which axis, you can't even go ahead. Find the moment of inertia about x-axis, y-axis, and z-axis. Okay, let's get this. Again, be careful. R is not the position vector. It is a perpendicular distance from the axis. And this result is quite important. We are going to encounter this again in gravitation and electrostatics. The result. The Think for a minute, and I'll show you. Listen. So this is again more of a geometry. Aditi. Yeah. Think you guys got it. Great. Let's see. If you just draw the picture carefully, you will notice it. So what we will do now, drop a perpendicular from here to the xy plane. So let this coordinate be x comma y comma 0. And at this point is your origin 0 comma 0 comma 0. So from here to here, if you see the distance, this will be root over x square plus y square. So now look at this carefully. If I take this green line and if I move it straight up, do you think the distance will change? Isn't this the perpendicular distance? Is that making sense? So this perpendicular distance will be root over x square plus y square. So it actually doesn't matter. So if you want perpendicular distance from x-axis, ignore the x coordinate. So this is the perpendicular distance from z-axis basically, what I showed you. So this is root over y square plus z square. You want perpendicular distance from y-axis, then ignore the y coordinate. So whichever axis you want, ignore that particular coordinate. If you want perpendicular distance from z-axis, then ignore the z coordinate. Clear? This result I want you to remember. It will come in another 3 more chapters: magnetism, electrostatics, and gravitation. And then you are done. So what is Ix? Ix will be m into y square plus z square. This is what I was saying. See, same particle, but depending on the axis, you get different moment of inertias. Iy will be m into x square plus z square, and Iz will be m into x square plus y square. Clear with this? Any doubts on this? There. So that is about particles. So particles, like I said, straightforward. So next thing we will do for continuous bodies. So take a break, come back by 9:45. We'll continue from here. Any doubts so far? Chalo, come back by 9:45. Chalo, let's start off. Next thing, more definition for continuous bodies. And we know in centromas we did the continuous bodies, rod, semicircle, all that stuff will pop up again. Let's cams on everyone. Let's see a question. Rudransh, clear with this?
Yes, sir.
Let's start with something simple, uniform rod. So we have a rod here, mass and length L. I'll show you one. And you want to find moment of inertia about this axis, the center. X is equal to L by 2, X is equal to minus L by 2, and X is equal to 0. You know this thing, whenever you see a rod, how do you choose an element? At a distance X, we take a small slice dx. Idea is still the same. This will give you a mass dm, which is lambda dx. Here, lambda is nothing but total mass by total length into dx. What is the formula for moment of inertia? Integral dm into r square. And what is our perpendicular distance? That will be m by l dx into x square. X ka value is going from minus L by 2 to L by 2. That would be m by L x cubed by 3. Substitute there, you'll get I is equal to ml square by 12. There, you need to mug up this result. That means moment of inertia about a center of a rod is ml square by 12. Clear how we did this? Like I said, it is more easy than center of mass. The elements will be same as center of mass again though. Now, using the same thing, I'll give you one more. Now you guys try. Let's say the axis is about the edge of the rod. Mass L, length L, moment of inertia is about the edge of the rod. Let's say lambda is equal to lambda naught x. What is the moment of inertia about that? The second one is also standard result, but let's derive fast. And others, do keep your cams on. Same story. Distance x, take a small slice dx. dm will be lambda dx. That would be m by l dx. Moment of inertia is integral dm r square. That's m by L dx x square. The only difference here, the limits in this time will go from 0 to L. This will be ml square by 3. And you can notice this. That means, understand the meaning of this. If you try to rotate the rod by catching in the center, and if you try to rotate the rod by catching on the edge, it is 4 times more difficult to rotate the body by catching at the edge. That's the meaning of it. The moment of inertia is 4 times more. It's 4 times more difficult to catch the body about the edge and rotate. Here, again, same stuff. That's what I'm saying. Once you know how to take the element, everything is just repetitive motion there. dm will be lambda naught x dx. So moment of inertia will be lambda naught x dx. That's your dm into x square, 0 to L. That will be lambda naught L power 4 by 4. Easy? Any doubts on this? Yeah? Any doubts? Let's go ahead with more cases of this. What if I keep the rod like this? This is the axis, angle theta, and rotating like this, mass m and length L. Means how is the rod rotating? Are you guys able to visualize how? Think of like this. See, if I stretch my hands like this, and if I rotate around, how it will be? Able to visualize how it is? Stretch your hands left and right. Now just tilt them like this. And if you rotate, so it's like a person who is standing like this with the hands, and you're rotating about the center. So this is your rod. Are you able to visualize? Get the moment of inertia of this rod. What if the same thing, the rod is like this? The rod is rotating like this. Yeah, we're just playing with the rod, but you can see how I'm, varying the orientations. See? So how do we choose an element? Be careful, X should be always taken along the rod. Because when you're choosing an element, dx must be in the direction of x only. You can't take x like this and you can't take dx like this. You can't have it two different directions. So let the distance be x. So this piece is still dx. Now what is the perpendicular distance? This is the perpendicular distance r, which is x sine theta. That is a catch. That's it. Nothing much. Rest of the story is same. What is dm? M by L dx. What is the moment of inertia? Integral dm r square. This will be m by L dx. R will be nothing but x sine theta ka square. Remember, theta is constant here. Limits will go from minus L by 2 to L by 2. This will be ml square by 12 sine square theta. Be careful. Theta is the angle with the axis and the rod. If you put theta 90, you get your first result. You can do the same thing for this also. So we get here moment of inertia will be, you'll get everything same, m by L dx, like sine theta whole square. Only the limits will change, 0 to L. This will be ml square by 3 sine square theta. Clear with this? Clear? Let's see one more.
Sir, can we think of it like an effective rod along the perpendicular direction to the axis?
You effective length of the rod, are you getting like that?
Oh yeah, I did. I mean,
Perpendicular
basis on that
distances,
one.
na? It is working out. Perpendicular distances, na? But can you do for everything like that? What if it is
Yes,
a
sir.
random shape?
Mm, well, it
वो check करना
depends. I
पड़ेगा.
mean, for some
Yeah,
special shapes, it works, I guess.
yeah. For some space shapes, it might work. What if the rod is parallel to the axis? Meaning the rod is rotating like this. Able to visualize how? Meaning, look at my thing. It's like if you look at my screen, it is rotating like this. This is the finger is my axis. The thing is rotating like this. Hmm. What is there to reply, Ray? These are easy questions, Srihari. Why are you talking like a first-standard kid, huh? Reply for the next question, then I'll tell you. I'll give you a tough one, then you answer for that. I'll give you. Which any questions, may what is there? I already know you guys know most of the results. Do it. Do one thing. You type a wrong answer, I'll reply. I'll tell you why you're wrong. You're right, so that's why I'm not saying anything. I can see your messages. There. What if you have a rod which is bent in the center like this? Meaning, if you see this is the top view, this is the axis. This is the rod. And this whole setup is rotating like this. Are you getting how? Matlab, stretch both your hands. If you have both your hands stretched like this, and then you're rotating around. What is the moment of inertia of this guy? So F is easy.
Sir, it's
Why all
perpendicular with.
points? Hmm.
Sir, in the G part, is it like perpendicular with the axis, or the rods are like this?
The rods are perpendicular to the axis. No, they're
So
in the same
it's
plane.
same plane, right? Okay.
Yeah. This rod is bent in the center. Meaning, think of like this: stretch your hands right and left. Now bring them like this at an angle, like a drill. So what about F ka thing? If you see for F, all are same distant, isn't it? All points are equidistant. So the length of the rod doesn't matter. Therefore, the mode of inertia is md square. It won't matter. What about G ka answer? Nere utsa. Right, Rishi Hari. Right, Arya. Again, remember, listen to this thing. Let's look at the top view. From there, you will see. In the top view, if you keep the rod horizontal, this is your axis. And if you bend the rod, suppose if I choose this point as A, and let's say if I choose this point as B, this is A, did the perpendicular distance change? When you bend the rod, did you change the perpendicular distance from the axis? You didn't change. If the perpendicular distance remains same, then the moment of inertia must remain same. So actually both are equal. That's what I was saying. It doesn't matter whether you keep the rod right, left, or something. As long as you keep the distance same, it won't matter. Since perpendicular distances from axis do not change, I remain same. So when you bend the rod in the middle, meaning keeping the axis same, so this moment of inertia will still be ml square by 12 as a horizontal rod. Easy? Clear with that? The next shape is an arc. I think this is one of the most easiest shape. So if you take an arc, again top view, do you guys remember centromers of an arc? Two r sine theta by 2 by theta. So if this is theta, if this is mass m and this is r, if this is your axis of rotation, you can clearly see all are equidistant. I is equal to mr square. There's no need to integrate. All points on the arc are equidistant from the axis. That means if you make this theta into 2 pi, means if you make a ring, or if you make a hollow cylinder, it doesn't matter. All have same moment of inertia as long as the masses and radius are same. If you take this hollow cylinder and compress it, it becomes a ring. Again, remember what matters is the perpendicular distance. The side view will look like this for the arc. Clear with this? There's no need to integrate. Since all the points are equidistant from the axis, perpendicular distance, they have same moment of inertia. Done. With that one line, you're done with the discussion. There's no need to solve. That's what I said. Moment of inertia is actually easy to, the calculations and workings are a little more easy than center of mass. Any doubts on this page? After arc, what shape we get? Disk. Uniform disk. The axis is passing through the center. Find the moment of inertia. This is there. If you're in HSC board, 12th standard, this is the 2 marks ka derivation. I know you know the result, but derive. Because then I will do something like this. I will say the density of the disk is equal to sigma naught r, and then you'll be gone. That's the reason you need to know derivations. You won't be so lucky like every time they'll give you like this. and they really want to harass you, they'll give something of this sort. Sigma is equal to sigma naught r sine theta. Sine square theta. Bas, you're dead. Matlab, look at this. The density not only depends on the distance, but also depends on the angle. So every point will have different density. Then we had to take an element and we had to do double integration. We can play with that, but okay. We will see something of that sort in a rectangle plate though. That's the reason you need to do derivation. At a mains level, you don't need, but advanced they will mess up stuff. So let's see. So how do you choose elements for a thing? First of all, I'll give you the result. You have to mug it up. So I about the center perpendicular to the plane is mr square by 2. So we choose an element for the disk. So at a distance x from the center, choose a thin ring. That is how you choose elements for a disk. So at a distance x, take a thin dx. Take out this ring, you will get a, and cut the ring. If you cut the ring, you will get a rectangle. I hope you remember this stuff. So this is x and this is dx. So this will become 2 pi x and this will become dx. So area of this thin ring will be 2 pi x into dx length into breadth. So mass of this ring will be mass per unit area, total mass by total area, which is m by pi r square into area of the ring. You can use unitary method. So that will be 2m by r square x dx. And then moment of inertia of the disk is summation of moment of inertia of rings. Isn't it? If you add all the rings ka moment of inertia, you will get disk. What is the moment of inertia of a ring? Just now we derived the formula. Mass of the ring into radius square. Mass of the ring is 2m by r square x dx x square, and limits will go from 0 to r. That will be r power 4 by 4. You end up with mr square by 2. Clear with that? That's how you choose elements and integrate. So if I give you something like sigma is equal to sigma naught x, big deal. Matlab, in place of m by pi r square, you'll put sigma naught x and then you integrate. Are you clear with this? So since you got this result, that means if you actually take a sector, same mass and same radius, remember that statement, as long as you keep the perpendicular distances same. That means if you take this sector and if you stretch it, did you ever see that fan? You know, these people have that fan, this Japanese fan. You open it. So it's something like that. If you open this disk, if you open this sector into a full disk, did the perpendicular distance change? Perpendicular distances don't change. So the moment of inertia is mr square by 2 only. So you have a full disk, you have a sector, or you have a solid cylinder. again, as long as the mass and the radius are same, they all have same moment of inertia, mr square by 2. Is that clear, everyone? So if you have a full disk of mass r and mass m and r, or if you have a sector of mass m and r, the moment of inertia doesn't change. Like I said, moment of inertia doesn't depend on how you keep the particles. Any doubts on this? Then let's see one more. What if I take a triangular plate and if I rotate it about the base? Mass m, height is h, the base is b. It's a uniform triangular plate. Find the moment of inertia about the base. Uniform right angled triangular plate. Are you able to visualize the picture? Meaning the book which you have, you just catch the edge of the book. Meaning, look at this thing. If I'm taking my phone, right, I know it is not a triangle, but if you take my phone and let's say it's like I'm catching on this edge and if I'm trying to rotate the triangle, you guys are able to visualize that? You're just catching the base of the triangle. So it's like a flag basically. The flag is rotating. I hope you're able to visualize the orientation. It's important the orientation should be clear. Because I have seen that most people they don't understand only how the picture looks and then they don't get the question. So that part is important. Exam I won't be there to tell you. So you need to learn how to see and figure it out. Get this? This is a pretty good one, and this result you should definitely mug up though. Not this. This will give you another good result. I'll show you. So, first, let's get this. Again, the important thing is always to choose how to choose the element. Try. I'll give you another minute. It's a good one if you can figure out. Right, Samyak. Neotsa. And right, Anvita. Right, Arya. Let's see. So how do we choose an element here? There are two ways you can handle. You can take a horizontal rods or vertical rods, right? You can choose anything you want, but I will take the vertical rods. You can take the horizontal rods. It works. So at a distance x from here, take a thin rod. And if you remember, this is how we started the whole integration there of dx. This is theta. So this height will be x tan theta. So now basically we got a rod about the edge. This is this question, isn't it? This question, na? B part. The rod about the edge. If you take the horizontal rod, then it will be F part. So doesn't matter, it works. So this is x tan theta, that is your length, and the width is dx. So the area of the rod dA will be length into breadth. So x tan theta into dx. So the mass of the rod will be the total mass m by total area of base into height into the dA. So mass of the rod will be 2m by bh into x tan theta dx, and tan theta is nothing but h by b. So I know that value anyways. Perfect. So what is the moment of inertia for the rod? If the rod is about the axis, this will be m rod into the length square by 3. In this case, it is 2m by 3bh x tan theta dx, and length is x tan theta ka square. This is the moment of inertia of one rod. And remember, x ka value goes from x is equal to 0 to x is equal to b. That's your base. So I of the triangular plate will be the summation of all these rods, which is integral. Add all these rods. That looks bad, but you actually get a very decent answer. 2m by 3bh tan cube theta integral x cube dx. This will be 2m by 3bh, and tan theta is nothing but h cube by b cube, and that will be b power 4 by 4. B gets eliminated, and you end up with mh square by 6. You get a pretty good answer. It doesn't depend on the base. The answer depends only on the height. You can make it even better. But did you get how did I choose the elements? Any doubts on the steps? So the headache is always, choosing the element properly and getting that. Once you get the integration will be always easy. It is simply x power n ka integration. This is a result you should remember. Imagine instead of a right angle triangle, we have a scalene triangle. The height of the triangle is h and the mass is m. Now, what we can do, we can split this triangle into two pieces, cut it in the vertical, so it will become two right angle triangles. Let the mass be m1, let the mass be m2. Height will be same for both of them. So this moment of inertia is m1 h square by 6, and this moment of inertia is m2 h square by 6. We derived just now for a right angle triangle. Therefore, the moment of inertia for the scalene triangle will be m1 plus m2 h square by 6, and m1 plus m2 will be total mass. So it doesn't matter. Moment of inertia of any triangle about the base is mh square by 6. But remember, this is about the base. It depends only on the height. It doesn't depend on how big the triangle you make. Are you getting how we proved for a scalene triangle using a right angle triangle? Because a scalene triangle can be split into two right angle triangles. Quite an important result. This itself can be a question in the exam. Any doubts on this? So that result need not be valid only for this. It's also valid for any scale in triangle. So then do for this. Let's say we have a right angled isosceles triangle. This is A. This is A and mass is M. Find the moment of inertia about this. So I'm not rotating about the base now. I'm rotating about that vertex ka parallel it is. Meaning side view will look like this. Someone kept a triangle like this and this triangle is going in a circle. I hope you're able to visualize. That thing looks like a Dorito type. So right angled isosceles. This is important because what I saw now, people get confused between this and the previous one and they write the same answer. So to be clear, let's do this. Then actually we can be confident, how to actually integrate a triangle. Now here, how will you choose an element? Hope the picture was clear. Mass M, the sides are A. Right, Samyak. We have one answer. Anyone else? I'll give another 30-40 seconds. In this case, it's preferable if you can choose elements horizontally. Because vertically doesn't make sense only. There's no rod only here to take vertically. Near idea. Let's see. Should get used to, meaning in the beginning it might look a little difficult, but that's what I'm saying. After class gets over, again, try it on your own. You do this few times, you'll get the hang of this. Right, Anvita? So after some point, right, you'll get, this will become pretty common. It's like bread and butter. You should know. If this is the shape, this is how you take elements. So from here at a distance x, let's choose a rod. Remember always x and dx should be in the same direction. So this will be dx. Now, because it's an isosceles triangle, this is 45 and this is 45. Luckily, so this is also x and this is also x. So the area of the rod dA will be length into breadth, which is 2x into dx. Mass of the rod will be mass by total area, half into base into this a square into 2x dx. That will be 4mx dx by a square. Now here, this rod is parallel to the axis, right? This is that d case. All the points are at a distance x. So I of the rod will be m of the rod into x square. That is the reason we did rod go all cases there. And then you're done actually. So for I of the triangle, integrate this I of the rod. That will be 4m by a square integral x cube dx. But what are the limits? You have to be careful. You're taking x from here. That's basically this width. That is a. So this will be a by root 2. The limits will go from a by root 2. That will become 4ma square x power 4 by 4 limit 0 to a by root 2. That would be ma square by 4. Is that clear, everyone? You're taking x from the top, right? So x ka value varies from 0 to a by root 2. Maybe the limits are messed up. Check it out. All clear with this? Right, Utsa. Any doubts on this? So there, triangles, be careful. Base is easy, but the vertex, it is something else. If this is a scalene triangle, you couldn't have done this. All clear with this? Let's see one more. Hollow sphere. How do you integrate this? Parallel axis, you can use it only from center of mass, na, right?
The center of mass is easy to find.
But then कर सकते हो. I didn't teach you, na. Why बोल रहे हो? Once you say like that, then I will come and say this is changing with x. So my main point there is to make you comfortable with that integration. Let's get this, everyone. Like I said, this is one pretty important shape, a hollow sphere. You saw this in center of mass. You're seeing a rotation. You will see this again in fluid mechanics, gravitation, electrostatics, magnetism, modern physics. This shape will keep popping up, and we will use the same element. In case you forgot, I'll show you. We did this for hollow hemisphere, though. Yeah, the element should take a ring. There, that is how the element will look. You take a ring of r cos theta and r d theta. So this is what I was said. This story will be always same for a hemisphere or a sphere. This story is always the same. Try. I'll give you a minute or two. Arya, did you actually solve again? Karna element leke. As if I don't know that you guys don't know you know the answer for this. What is the point of just saying the answer? Hey, this is what I was saying. Advanced exam, you guys won't be so lucky. They will simply say the angle, this will be sigma is equal to sigma naught sine theta. And you're dead. You don't know how to integrate for that. So how do we choose the element? Definitely try to do this again on your own afterwards. I'm repeating the same thing, element. So this is angle theta. Right? We take a small d theta. So this element will look something of this sort. How to think of this? Take a watermelon, cut it horizontally like this, you will get a disc. Then remove the red color part from the middle. Then you'll get a green color band. Able to visualize that? That is how the element will look. Perpendicular, so this will be r cos theta. This is r cos theta and this is r d theta. Axis is passing through the center. So area of the ring, circumference 2 pi r cos theta into width r d theta. Mass of the ring, total mass by total area m by 4 pi r square into area of the ring 2 pi r square cos theta d theta. Moment of inertia of the ring, mass of the ring into radius square. Mass of the ring will be m by 2 cos theta d theta. Radius of the ring is r cos theta cos square. So I of the hollow sphere will be mr square by 2 integral cos cube theta d theta. You should know how to integrate this. And the limits will go from minus 90 to plus 90. Why? At the center, theta is 0. If you go up, you are covering 90 degrees. If you go down, then you're covering minus 90. So when you go from plus 90 to minus 90, it will go off. Now, this is important. You know why? Examiner, they'll ask you something like this. What if it is not a full sphere, but it is a part of a sphere? And they will say this angle is 60 degrees. Then they'll ask you find moment of inertia. So it's not difficult. You just have to change the limits. So limits will be from 60 to 90 and you'll get the answer. That is the reason I'm telling you should know how to derive an element. So how do you integrate cos cube theta? Anyone remembers? This is a little different. So listen, cos cube theta. No, right now it might feel difficult, but when you're in 12, this will be a joke. So we actually use integration by substitution. We can write this thing as 1 minus sine square theta cos theta d theta. So we put cos theta is equal to t. Differentiate on both sides. Minus sine theta d theta will be dt. When you put put sine theta is equal to t. Cos theta d theta will be t. When theta is equal to 90, t is equal to 1. When theta is minus 90, then t is equal to minus 1. This will become minus 1 to 1. 1 minus sine this t square. Cos theta d theta is dt. There it becomes a simple integration, t minus t cube by 3. Limits will go from minus 1 to 1. 1 minus 1 by 3. Now substitute minus 1 minus of minus plus 1 by 3. That would be 2 by 3 minus of minus 2 by 3. That's 4 by 3. Substitute here. Mr square by 2 into 4 by 3. 2 by 3 mr square. There. You can mug up the result, but that's how you derive this. Yeah, you can also use cos cube formula and do it. Clear with this. So using this, can you find the solid sphere now? So solid sphere is nothing but combination of hollow spheres. Let's finish off. Last one for the day. Again, I know you know how you know the result, but let's find it. Because then exam will ask you this way. Rho is equal to rho naught r square. Density is changing with r. Find the new moment of inertia. You should know how to choose your elements. So you can use, it's like onion ka shells. A solid sphere is a combination of multiple shells. Let's try this, everyone. Focus, focus. Don't get tired now. Right, Utsaha, you know, you got the results, but I hope you guys derived it again. Let's see. So we consider a hollow shell. Thin shell, radius r, thickness dr. So what will be the volume of the shell? Surface area into thickness. Surface area is 4 pi r square and thickness is dr. So mass of the shell will be total mass m by 4 by 3 pi r cube into 4 pi r square dr. This will be 3m r square dr by r cube. And then we know moment of inertia of a shell. Just now we derived is 2 by 3 m shell r square. So this will be 2 by 3, 3m by r cube, r power 4 dr. I of the solid sphere will be 2m by r cube integral r power 4 dr by 0 to r. That would be mr 2 by 5 mr square. Clear how we did this? You could have taken disks also. That would work. But I use shells because I already know shells. Clear with this? So there are a few more shapes, right? Next class when we catch up, we will see how to find for a rectangle. And then we have two theorems here called parallax theorem and perpendicular theorem that will help you, you know, it will save you time from integration. We get some pretty good results without integration with that. So next class when we do, we will wrap up the rotational, you know, the moment of inertia part. And then maybe if time permits, we will do no slipping condition. So maybe after next class, we will be done with the basics. It's like before cooking, we are done cutting vegetables. Right? I know it's a lot of vegetables you're cutting, so but if you ask someone who is cooking, right, the most irritating part and the difficult part is cutting vegetables only. Cooking is actually easy. ठीक है. Yeah, so with that we'll wrap up for the day. And do remember there's a test online. Like I said, I extended the deadline till Saturday 1 o'clock.